Meteorology! What is you, sir?
I'm Peter, the intelligent one.
I am Andrew, the student. Faithful student.
And mildly, never mind, I'm not gonna go there. Next slide. Weather is the current state of the atmosphere, the way things are right now.
It happens all around you, no matter what, right?
Yes.
I mean, like right now, it's raining.
It is?
Yeah.
Yes, it
look
is.
out the window,
It is.
yeah.
It is.
All right.
Climate is the general, is a
Long-term variation.
The long-term variations. That's why I'm not the smart one apparently.
Nah, you're the
the
teacher. You're doing good. You're doing good.
That's the long-term variations of weather patterns over a particular area. For instance, here it's
Like
pretty random.
Temperature.
Or barometric pressure, or wind speed, so on. Fronts.
Fronts, sir.
Fronts are narrow regions between
Separating two air masses.
Separating two air masses. Separating two air masses of different densities, temperatures, so on.
You know, like you see on the Weather Channel, guys. Showing the fronts.
Little
Showing
lines,
the full fronts.
little lines with
semicircles and triangles.
You're not a part of this. For instance, we have a cold front. That's why it says cold.
Okay.
Warm front, why it says warm.
Alright. Here we got a thermometer.
Which is used for measuring temperature. As the heat rises, obviously the fluid rises with it.
Is
mercury.
Mercury, whatever. That's a fluid, isn't it?
Yes, it is.
A barometer, used for measuring air pressure or barometric pressure.
Like when the air gets cold, the pressure eases, gets real thin. And then when it gets real hot outside, you know, the humidity gets up there, the pressure rises.
What he said.
Yeah.
Now we have an anemometer. Is it anemometer?
Anemometer.
Anemometer. I apologize. This measures wind speed, as you see by the weather vane here.
Like, these are mostly used for around like tornado alleys, because these things can like...
Well, not necessarily. You can use them in all sorts of things. Even just around the school if you want to know what the weather patterns are.
It's just the wind speed.
Or where to plant a windmill.
It's just the wind speed.
Geothermal energy.
You're not a part of this.
The hydrometer.
Used for measuring relative humidity.
Humidity is that stuff. You know when you go outside and you just feel all that pressure inside you?
Your hands feel sticky and you feel wet. Sucks.
Yeah. That's water in the air. You are breathing water.
Water
Water
vapor.
vapor.
You're not a part of this.
Okay. Yes, sir.
We have a celiometer.
Celiometer.
Celiometer. Used for measuring rainfall in a given area.
Measuring rainfall.
Sorry,
Like
rainfall.
you stick
Yes.
it up. You stick it out in the rain. The rain is falling to the ground, and this fills up and it measures your rainfall. Is all you could use a cup, but
Yeah,
one of these fancy gets
apparently a bunch of scientists decided this was better. Anyway.
You know, you could use the cup and really. Winds
Blow from high to low.
Yeah, high to low.
High to low.
Like winds blow from straight up high, just straight down. That's just how it goes.
We have
Convection.
convection. Right? Yes.
Convection.
Big word, kids, but we think you can learn it.
Yeah, convection is the major mechanism of energy transferring the ocean's atmosphere to Earth's interior.
Yes.
Alfred
Wegener. It's German.
Wegener.
You're not a part of this.
Wegener.
You're not a part of this.
Wegener.
Anyway, he was the first to come up with the idea of the continents joining together. Needed this to prove his idea. You know, like those puzzle pieces back in elementary?
Yeah,
Stuck
yeah,
it
and
together?
all us kids said to our teachers that they looked like they, fit like together like a puzzle. And we were right.
Pangea.
In your
Right.
face, Mrs. Burns.
Pangea.
Who's Miss Burns?
Pangea.
My first grade teacher.
Oh, really?
Pangea. Pangea.
Mine was Miss
Why does this matter?
Miss
Stewart.
Smith.
Miss
Miss
Stewart.
Smith.
That's
Miss
great.
Smith was a
I'm not part of this.
Pangea.
Yeah.
Van Allen radiation belts. At first I thought this was Van Halen, but
Yeah.
apparently I was wrong.
Particles are deflected by the Earth's magnetic field from solar winds. You know, like those things. But the sun,
That really blows.
it does, you know? The sun shoots off these flares.
They're particles. They're solar particles.
Solar
Isn't it?
winds.
Yeah.
Radiation.
That's it. Radiation. Solar radiation.
It
but they're
blows
particles.
throughout the solar system and Earth. Catches them. Catches them.
The
No, it
magnetic
doesn't.
In
It
the
doesn't
thermosphere, in the Earth. That's why you get all the beautiful lights up in the sky.
Yeah,
Aurora
the big
Borealis.
greenhouse lights, aurora borealis. Sometimes during a big solar flare, they can occur as far south as what was it, Mexico?
What?
During a big solar flare,
Antarctica.
Antarctica. My bad.
Antarctica.
But I mean, they can come down to the as far as
Iceland is the
equator.
lowest they've gone.
No, they don't.
No, from like they.
Anyway.
Alright.
They haven't gone.
Alright,
We have track.
the particles are trapped in two huge rings in the Earth. The magnetic field called Van Allen belts.
Van Allen belts. I'm a Van Allen fan.
Alright, this diagram right here, it shows the entire water cycle. Why are you embarrassed, sir?
Embarrassed to explain.
Alright, it shows the entire water cycle.
We have evaporation on this side. Don't do it. It's
The
transported.
water cycle!
He's very passionate. He's very passionate.
You
About
must learn it!
Please excuse. Please excuse his behavior. Anyway, we have evaporation, which is transported via clouds, which is just condensed water vapor, and then it's
the
precipitated down
water
on the land, where you have it in estuaries, lakes, rivers, etc. Eventually, that gets back to the ocean via runoff through streams or just through soil runoff.
The water cycle, man. The water cycle.
Anyway, I don't remember what this was, so Andrew, this is your cue.
Pressure.
Fronts.
We need a minute to review, Andrew.
Warm fronts. Warm fronts.
The
Low
warm
pressure.
fronts, when it goes warm, if the pressure goes cold, right?
Yes. And then
Alright, they go
warmness.
cold, the volume, the pressure, the temperature warms up, but the volume goes down. The density, temperature goes down, density goes up. The humidity, the temperature goes up. That pressure is supposed to, or the cold goes down. The temperature goes down, cold goes up. It goes up real fast. You gotta be prepared when that cold comes in. Whoo, it gets cold.
That it does.
Alright. Storms.
These
I
are-
got hurricanes. I want to do hurricanes because I rock like a hurricane.
No, you don't, first of all. And secondly,
No storm.
tornadoes are primarily formed over land. Formed when
Two
a
fronts
hot.
collide.
I know that. When you have, I'm the smart one, remember? Then we have the,
You're not.
when two fronts collide and begin to rotate.
It begin to spin in the air. First, it's like this.
Yep.
And then that tornado flips over. It's like, and it goes, it blows over houses. The highest it can go up to is a category 5. No.
F5. F5. Vegeta 5.
The Vegeta scale. Invented by some Jap. We don't know who.
No,
I've had enough with your attitude. I'm doing this live. The mesosphere, the stratosphere, the troposphere, thermosphere. That's where all that
This is
northern
where
lights, the northern lights are right there.
Yeah,
That's
satellites.
the satellites go all around the Earth.
Cool your chest. This is also where satellites orbit. Then we have the mesosphere, which is it's also where the space shuttle flies, obviously. Then we have the mesosphere, then the stratosphere, right? Then the troposphere, which is the closest to the Earth.
And then you have the Earth.
Airplanes generally fly between the troposphere and the stratosphere, and hot air balloons generally pretty close to the Earth.
Why that balloons?
Weather balloons, hot air balloons, weather balloons. That's not a weather balloon, it's hot air balloon. Which button is it? That it? That's it. Yeah, we're done. Ah! No!
Everybody was kung fu fighting.
I should have that slide. The water cycle!